Hi, this video we're going to look at a WebWorks problem. This is regarding moment of inertia. And you have this shape, it's an I shape, and they give us a dimension, and basically this I shape is made of like three rectangles, right? And they ask a few things, simple things, however, it's going to be tedious. The first thing I ask is the centroid, the y location of the central of the shape. Um, and of course, they give us the coordinate here, x and y. They want to find where centroid is going to be. Centroid likely going to be somewhere here, right? Because it's top heavy. So that's going to be likely where our centroid axis will be. So they want to know how far is this our coordinate for the centroid. That's the first step. The second step, they want you to find the second moment of area of a shape about this x-axis. Okay. Then the third one, it's about the y-axis. Then the last one is regarding moment of inertia regarding this horizontal axis through the centroid. So basically regarding the centroid axis. So first of all, we're going to figure out the centroid. For this, we know centroid is quite easy to do, right? Centroid, we're going to looking at the formula. X bar is going to be summation of all those area and summation of x tilde delta a. That's going to be our for x. But x we don't are solving. We're solving y bar because x is going to be, centroid is going to be here. X is going to be equal to 0. So this should be equal to 0. But what we are solving is the y bar. So it's a summation of all those three rectangle and tilde, y tilde, delta a. Okay, so that's what we're going to do. So for this, we're going to look at those three different triangles. So I'm going to make a, this is going to be shape 1, 2, and 3, okay? Since if we're going to go ahead, then we have our shape 1 and 2, and then we have our 3. Then the area of 1 will be B times A. Then we have x tilde. We're going to actually just look at y tilde. Y tilde for that. So if we're drawing the dot for centroid, what's that coordinate? That will be C plus H plus half A. Okay? That's y coordinate. And this middle rectangle have the width W, the height is H. And this y tilde is going to be right here. And how do we calculate? It's going to be C plus half of H. Right? Then let's look at bottom rectangle. The area is going to be D times C, and y tilde will be half C. So knowing all that, you can put all those in your Excel sheet. Then you can go ahead and solve it. So what I could do is put all those in Excel, and then you create another column in Excel that will be like A times y tilde. So you get all those values, and then you find the summation. Then you get the summation of the area, and you also get the summation of the y tilde times delta A. Then we can go ahead and solve our y. So that's taking care of the first step. Again, I encourage you to use Excel, help you troubleshoot. Then let's look at Ix. Okay, in terms of Ix, we're going to look at x-axis is right here, right? In that situation, we're going to basically have three shapes. The top one, with regard to x-axis, will be around there. Then plus our middle one, and that's our 2. And the x-axis is also below that. then have a bottom one, right? Bottom rectangle, 3, and this is going to be the x-axis. So it's going to be all those 3 together. Now let's thinking about, so for the top one, the first one, that's going to be, we know regarding its own centroid, it's right here. And the formula for regarding own centroid is 1/12 base. Our base is b, our height is a, so it's going to be a cube. Then we're going to plus, using parallel axis theorem, will be a times b, the area, then the distance is that. And what's our distance here? So it's basically from here to that. Then what do we have? It's going to be, I'm going to bring it over here. So I'm going to move this right here. So then plus area AB, and the distance is going to be C plus H plus half A square. So that's going to be I for this top rectangle. Now let's look at the bottom of the middle rectangle. The same thing, we know the centroid for this is going through its own there. So that's going to be 1/12. Then what's the base? It's W. The height is H. So WH cube. Then plus the area WH. And now we're going to figure out the distance. The distance is going to be from this centroid to this bottom, which will be C plus half H square. So that's going to be for I for that. Now the very last one, that's going to be straightforward because it's on the base, and we know the formula for rectangle on the base is just going to be 1/3, right? 1/3. The base is D and the height is C, so 1/3 DC cube. So those are the 3 things. When you add them together, that will give you our IX. Again, I encourage you to go ahead and solve this using Excel, okay? Now, we're going to look at IY. In order to do that, I think I'm going to see if I can copy this again. Okay, so in order to solve this IY, we're going to do the same thing. Look at the top rectangle. And now this time, IY is basically going through there. That's going to be how that's related. Then plus this middle one, 2, it's also going through its centroid. Then the bottom one, 3, it's also going its centroid. So those are the 3. Now we're going to get our dimension here. So this is B, this is A, this is going to be W, this is going to be H, and this is our D, this is our C. So knowing that, IY, for the first one, the formula for that is going to be, going through centroid is going to be 1/12, and this time is y-axis, so it's going to be A times B cubed. B is being cubed. And the second one will be again 1/12, but this time it's going to be W being cubed because it's distributed away from y-axis, so it's W dimension. And for the area 3, it's going to be 1/12 CD cube. Alright, so that's easy. We don't need to use parallel axis theorem because all the y-axis happen to be at its centroid y-axis. So that's taken care of. Alright, and the challenging part for this problem is the very last one, because they ask you what is the moment of area regarding this neutral axis. This NA means neutral axis. And neutral axis is basically, it's the through the centroid. So remember at the first step, you can find out where this centroid is gonna be. That's our first step right here. If you know that value, then you can go ahead using parallel axis theorem for that situation. Then you can go ahead and go back. So doing something like, let's see for example, okay? So here you have the top one right there, and x prime is somewhere there. Then you are going to plus this middle one, and x prime is somewhere around there, right? Because it's like on the upper top. That's going to be the x prime. And then if you look at the bottom one, it's going to be below the x prime. That's what we are solving for this I regarding neutral axis. So in order to do that, again, we're going to use parallel axis theorem for every single one of them. You're going to find each individual centroid, right? And then this x prime is basically the new axis. Each individual centroid for each individual shape. So for this will be 112. Again, the dimension here is b and a. So it will be 12ba cubed, just like what you have right here. However, this distance is no longer different. This distance is no longer the same because it's going to be area a times b, and the distance between this centroid of this rectangle to this new axis. This new axis happens to be the centroid axis for the entire composite area, right? And so what's the distance there? So imagine, imagine if you figured out x prime to be a value, right? Let's just put some number there. Imagine if this y centroid you calculate right here. Let's see, C is 17, I'm putting my numbers in, and my H is 115, and my A is 19, okay? And if we happen to calculate this happen to be 80, okay? If this value is equal to 80, so that's from right here to here, that's 80. Then we're just going to figure it out, like if this value is at the base, that's going to be x-axis. If this is 80, right, and you want to figure out the distance here, what would that be? That would be distance, this entire height, a plus h plus c, right? That's the entire height minus half of the a, then minus your 80, then square. Okay, that would be something like that. So for every single problem, you're going to figure out this distance, and so you're going to try to figure out for this one and that one individually, and then add them all up. You can find out this problem. Again, encourage you using Excel. Hopefully that's give you some kind of clarity how to solve this problem. All right, I'll see you next time. Bye.